Today's the day, the perfect balloon experiment. I've added just the right amount of gas. It's time, it's going to work.
Dr. Volume, did you check all the variables? Pressure, temperature?
I think so. Maybe. Honestly, I just got excited and pumped it up. Beep, 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 beep. Oh no, something is wrong with the balloon experiment. It's either gonna pop or float away. The numbers aren't right.
You called me in, Doc?
Whoa, I'm building the tension in here.
And it's increasing. The pressure's rising.
Whew, it's hot in here. I may have turned the heat up just a tiny bit, give it some lift.
Hold on everyone, let's not panic. We're dealing with the ideal gas law here. PV equals nRT. If we change one thing, everything else reacts.
Yes, if P goes up and T goes up, V will...
Too much pressure and we're all wearing blue.
Don't blame me, I just brought the heat.
Okay, if we want to keep the volume steady, we need to cool the temperature or release some gas. Right now, and the number of particles is way too high.
Well, how do we release the gas safely?
Done. Gas release. Pressure dropping. Temp stabilizing. Volume ready.
Wow, well done, Nikki. You saved Lab 47.
That was intense.
I'm sweating science over here.
Let's write this down. If you mess with the pressure or temperature, you must balance it with volume and gas amount, or chaos.
PV equals nRT. Science saves the day. Hey guys, hope you enjoyed that video where you saw a real life scenario in our made up lab called Lab 47 and our characters
Dr. Volume,
Lab Assistant Nikki,
Captain Temperature,
And Agent Pressure. In our video, you heard us mention this equation. PV equals nRT. This is the ideal gas law. Now you may be asking, what is this law and what does this equation mean?
But first, let's look at the relationships in the ideal gas law. So P, V, and T, which are pressure, volume, and temperature, are directly proportional. So if one goes up, the other goes up. And if one decreases, the other decreases. But this only happens if the gas, mass, and the number of particles in the equation remain constant.
so what does the equation stand for? P stands for the pressure, V stands for the volume, and N stands for number of gas particles in moles. The R stands for universal constant and T for temperature.
But you may be wondering where this ideal gas law comes from. Well, it actually came from these three different scientists: Boyle's law, Charles' law, and Avogadro's law. Both of them had their own individual laws pertaining to the same gas laws, and they used different symbols to discuss the same variables. So because they discussed the same thing, a combination of all three of these laws was created to create the ideal gas law.